Boa tarde a todos, boa tarde a todas. Muito obrigado novamente pela participação de vocês. Vamos dar início à sessão. Meu nome é Vitor da Silva Carvalho, eu sou gerente da editora Karger aqui no Brasil. Essa iniciativa ela é fruto de uma parceria entre a editora Karger e o portal de periódicos CAPES. Então, um agradecimento especial a Andréa Vieira, Armando Peixoto, Stefânia Ribeiro e Cláudia Machado, e obviamente a Graham McNamara, que está aqui. Eu vou passar brevemente um vídeo do portal de periódicos, vou ler algumas informações sobre o portal, eu faço uma breve introdução sobre a editora Karger e depois a gente dá início na sessão, beleza? Sobre as perguntas, primeiro a sessão ficará gravada e sobre as perguntas vocês podem colocar as perguntas na parte de Q&A que a Grania vai endereçar no final do webinário. Então ela vai fazer a apresentação em inglês. Então, se vocês quiserem, vocês podem colocar as perguntas tanto em inglês ou em português, e aí durante a sessão eu tenho tempo também de traduzir essas perguntas para poder endereçar para ela no final, beleza? Muito obrigado mais uma vez pela participação, pela parceria de todos vocês. Espero que possam tirar proveito dessa sessão. Bom, o portal de periódicos da CAPES é um dos maiores acervos científicos virtuais do país, que reúne e disponibiliza conteúdos produzidos tanto nacionalmente e outros assinados com editoras internacionais às instituições de ensino e pesquisa do Brasil. São mais de 39 mil periódicos com texto completo, 396 bases de dados de conteúdos diversos, como referências, patentes, estatísticas, material audiovisual, normas técnicas, teses, dissertações, livros e obras de referência. Ele foi criado para reunir material científico de alta qualidade e disponibilizá-lo à comunidade acadêmica brasileira. Assim, o portal de periódicos tem o objetivo de reduzir as assimetrias regionais no acesso à informação científica, cobrindo todo o território nacional. É considerado uma iniciativa única do mundo, pois um grande número de instituições acessa o acervo que é inteiramente financiado pelo governo federal. O portal de periódicos propicia o desenvolvimento tecnológico e a inovação no país por contribuir com o crescimento da produção científica nacional e a inserção cada vez maior da ciência brasileira no exterior. É, portanto, fundamental as atribuições da CAPES de fomento, avaliação e regulação dos cursos de pós-graduação. Brevemente sobre a editora Karger, para aqueles que não estão familiarizados, a editora Karger é uma editora global, com a sua matriz na Suíça, na cidade de Basileia, e ela possui escritórios regionais em mais de 15 países no mundo. Começou suas contribuições em 1890, nós temos publicações originais de Freud, por exemplo, entre outros pesquisadores que receberam um prêmio Nobel, então realmente é uma editora bastante tradicional, e ela foca todas as suas contribuições 100% em ciências biomédicas. Em termos de portfólio, nós temos 105 periódicos, são publicados pelo menos 30 novos livros ao ano, mais de 80 sociedades médicas internacionais publicam oficialmente nos títulos da Karger. Então, sociedades mundiais, como a Associação Mundial de Psiquiatria, Associação Mundial de Broncologia, Academia Internacional de Citologia, todas essas sociedades que reúnem diversas sociedades de diferentes países, várias utilizam os periódicos da Karger como o veículo oficial das suas publicações. São mais de 200 editores-chefes, 3 mil editorial board members e aproximadamente 18.600 revisores que fazem essa engrenagem da publicação científica na Karger funcionar. O portal de periódicos oferece acesso a 18 títulos da Karger em diversas especialidades, então, nutrição, odontologia, genética, dermatologia, gastroenterologia, endócrino, imuno, neonatologia, enfim, diversas especialidades neurocirurgia pediátrica, psicologia, psiquiatria, pneumologia, entre outros. Então, se a sua especialidade é de algum desses títulos, eu convido vocês que vocês possam, através também do portal de periódicos, conhecer as pesquisas mais recentes que foram publicadas nas revistas científicas da CARG, beleza? Outra iniciativa, um livro que estamos disponibilizando gratuitamente. A editora publicou esse livro originalmente em inglês, mas fez questão de traduzir também por essa parceria com o portal de periódicos, e nós estamos disponibilizando conteúdo gratuito. Então, como conseguir publicar o seu artigo biomédico, é um guia prático, é uma leitura extremamente didática, compartilha ali os fatores críticos de sucesso, né, no momento da publicação. Então, quais são os fatores-chave da introdução, método, resultados, o que fazer, o que evitar, quais são aqueles erros que não se podem cometer e como realmente deixar o seu manuscrito com mais chances de ser publicado e não simplesmente um manuscrito que tem maior chance de rejeição. Ética na pesquisa e publicação em tempos de ciência aberta. Então, nós temos a alegria de ter a palestrante aqui hoje, que é a Grania McNamara. Ela é gerente de integridade de pesquisa, ética de publicação na editora Cargier. Ela lidera uma equipe responsável por desenvolver as políticas de integridade de pesquisa e conduzir as investigações sobre esses aspectos em todos os periódicos da editora. Ela recebeu o seu PhD em Neurociência Integrativa pela Universidade de Cardiff, no Reino Unido, e atuou como pesquisadora na Universidade de Cardiff, em Londres, antes de passar a trabalhar com integridade na pesquisa e publicação de livros e periódicos científicos. Okay, now switching to English. Grania, thanks once again for your time, for your availability, and for your kindness. For really embracing this project, these ideas since the beginning. We're really happy to have you here, sharing your knowledge, your insights on ethics in research and publication, especially bringing this focus of open science, which is a very important topic and will become more and more important in the next years. And so again, thanks a lot. And now I hand over to you whenever you want to share your screen and start, please feel free.
Thank you very much. I will. Okay, Victor, can you give me a thumbs up if you can see it? Okay. Well, thank you everybody for having me today, and thank you for giving up your time as well on this Friday to spend some time thinking and talking about ethics and open science research. Today, I really want to focus on the practical. You can read about the benefits of open access and open science and open research online. And I encourage you to check your funder and your institution requirements around this topic. But I'm going to assume that if you're here today, you have some sort of interest or a requirement to engage with open science. And I want to really focus on how you can do this practically and in an ethical way for your benefit, for your career's benefit, for your research's benefit, as well as for the general public and society's benefit. So we talk at Cargier a lot about the cycle of knowledge. And here is a much simplified version of that. So I'm going to focus on some of the time points inside the cycle of knowledge and how you can think about open science and open science practices for your research and your team's research. So first of all, I'm going to start off with a little bit of background and framing about why you're giving an hour or more of your time on a Friday to this subject. As Victor mentioned, there is a question and answer box, so please feel free to put any questions in there and we will spend some time on those at the end. So, Victor, if you could launch the first survey or first poll, please, that would be great. So I wanted to start today with a little bit of self-reflection for you. As I said, you're giving up your free time on a Friday, and I want you to think about what you hope to achieve when you're doing research. So you can tick as many boxes as you think applies. What do you want to achieve? Are you thinking about the impact that your research makes on the field in general? Are you thinking about how your research impacts maybe patients? Do you want to be well regarded by your peers? Are you thinking that you want your research to be well respected and read and distributed widely in the field? I think there's lots of reasons why anybody gets involved in research, and they're all very personal. But I picked out some of the key topics that have come up when I've talked to researchers before, as well as when I was a researcher as well, and I thought about these topics. So I can see that there's a lot of answers coming in, and it's really interesting. So, Victor, can we end the poll now and share the results so people can hopefully see as well? So I find this really interesting. I think that for most people, there's lots of different reasons why they do research. Want to add knowledge to the field, want to progress in your own career, of course, want to make an impact, want your research to be cited, maybe slightly less wanting to be published, or have your peers think highly of you. What I think this really nicely aligns with is the results from a study that was published in PLOS in 2021, which asked researchers to think about what matters to them in terms of personal satisfaction, or what in their job gives them personal satisfaction, and what do they think matters for progressing science. And what was really nice is that some of the same things that mattered here, such as getting published and being cited and making an impact, came up in this survey as well. So it's a universal sentiment that we're expressing here, that you are interested in not just your own publications, but in adding value to the field and so on. So, okay. I think it's important while we're all here today that we have a common understanding of what we're talking about when we say open science, at least for today. So whenever you read articles online or listen to other speakers, there can be a little bit of variation in how people define open science in terms of, the breadth of subjects or the emphasis. And I think that's normal. Open science is very important, as Victor said, field, and it's moving very quickly. And I don't think there's a need to be limited by fixed definitions. However, I do like the definition from this UNESCO report from 2021 on what is open science. So this is a big block of text. So I'm going to highlight the elements in this that are important to me and that I'm going to focus on today. So UNESCO point out that open science is inclusive and accessible for everybody. So when we think about inclusivity, this refers to your fellow researchers and ensuring that authorship and contributorship is openly discussed and agreed upon collectively, reflecting everybody's contribution. It's accessible, meaning that that your colleagues are not excluded from contributing to the research because of maybe systemic barriers or historical barriers. Accessible research is reusable, meaning that your methods, code, and data can be reused by your team and by others, reducing waste or redundant work in the research cycle and improving reproducibility of research, a concept we'll come back to. But inclusivity and accessibility also refers to those not on the research team. So research in open science is made available to those interested or affected. So be they patients, journalists, politicians and lawmakers, or just members of the public with an interest. This is where the importance of making research accessible through translation to other languages is important. And I think it's often not mentioned in discussions about open science. So I think as a researcher, to reach as many people as possible, you have to meet people where they are. And I think that is language is often a barrier there. I'm presenting this in English. I'm sure that for many of you, maybe English is not your first language. Similarly, if I was presenting this in Irish Gaelic, all the points that I'm making for most people probably would be missed because I don't know how many Gaelic speakers there are in the audience, but I would imagine maybe not many. So I think that it's just important to consider when disseminating research that it is through the language of the individuals that you're trying to get that research to. And I really, on that point, I think this report really neatly summarizes why you're going to all this extra effort to embrace open science and open research. So we want to make the process of research and using science to benefit as many as possible. And this is really at the heart of Carragher's mission to bring knowledge to people throughout the cycle of knowledge, not just researchers themselves, but to patients and practicing clinicians. And I hope that at the end of today, it can be at the heart of your research as well. Okay, so after that sales pitch for open science and open research, I wanted to do another survey. So maybe Victor, if you could launch survey 2 or poll 2. Now this one has a little more options and it's about what practices related to open science are you already doing? Now, tick as many as is applicable to you. You might be surprised about some of the options that are listed here as being considered part of open science. You might be surprised that you're actually doing quite a lot of the items listed here, but hadn't been thinking of them as being part of open science. You just didn't think about them in that framework. Some of you might be thinking, uh-oh, yikes, there's a really long list of things here and I'm not doing any of them and my team don't do any of them. And that's totally fine. We're all here today to focus on the practical, big and small things we can change in our research in order to embrace open science a little bit more closely, and how we can take messages that we're learning today back to our research teams who aren't here today and advocate not only for these open science practices, but explain why they're important and why you think it's necessary that we, for example, pre-register the study protocol or publish your research as a preprint. So I'm seeing a lot of answers come in. And of course, I didn't leave a none of the above option. So that's an oversight from me. So sorry about that if you're looking for a none of the above. But yeah, this is a judgment-free zone and we're all here to learn. So I'm looking forward to hopefully everybody being able to take something away from today. So I think we can close the poll now. We've got quite a lot of answers in and the responses are slowing down a little bit, and maybe share the results with everybody.
Done.
Brilliant. Thank you, Victor. So what you can see is that there's a bit of variety in what people are already doing, and that there's what's really nice to see is that nothing is empty. So people in the audience are engaged in at least some of these. And I hope that by the end of today, maybe you'll be planning on being engaged in a few more. Okay. I assume if you're here today that you have some sort of interest or investment in open science. And I'm going to ask you to do another poll. So if you could launch poll 3, please, Victor. And so this is really thinking about, why does open science matter to you? Maybe you're here because you're interested. Maybe you're here because your boss said you had to come. Maybe you're here because your funder says that you must embrace some open science principles and you're looking for information on how to get started. But if you're here just out of interest or looking to be convinced about open science, for this question, I'd like you to ask yourself, why do you think open science matters? Why do you think it's important that research is inclusive, accessible, reusable? Is it, maybe you don't think it's important at all, but maybe try to think of some of the benefits that could arise from inclusive, reusable research. And thank you for everybody. I can see the answers and the responses coming in. I'll just wait for them to slow down a little bit. Okay, I think we can end it there and share the results. And so I think that there's quite a lot of agreement around open science can make research more impactful. And maybe we could talk about some of the ways that we think it can be made more impactful or maximize the impact of the research through little tweaks to your research program to reach maybe a broader audience than previously. So thank you, everybody. I hope I stopped sharing there. Okay. So of course I'm asking you this question for a reason. And earlier I asked you all to think about what you hope to achieve when doing research. And I hope that you can see, or you're at least a little bit convinced, that the benefits of open science for society, the reasons that it's good, that science is more inclusive and accessible, are the same reasons, are the same things that you hope to achieve when doing research. And so by taking actions that benefit your research career, you can be benefiting open science, and vice versa. By engaging in open science practices, you can be benefiting your career. And we're going to talk about some of the practicalities of that. Yes, I promised that I wouldn't focus too much on the philosophical today, and I won't. So let's get started. So I have mapped some of the open science practices that I talked about earlier onto that cycle of knowledge, so that we can take a little bit of a closer look at it. Now, this isn't a neat designation, of course. You can share your code during the design stage of your study. You might responsibly engage with Indigenous communities during the dissemination stage of your research. All of it melds together, but for today's purposes, this is the framework that we're going to think about. And equally, I want to point out that I'm not suggesting that this is by any means an exhaustive overview of all of the important things to think about in open science. I already mentioned the importance of ethical authorship practices, and we're not going to have time to talk about that today, but if you have any questions, again, leave them in the question and answer box, and we can talk about that later, or I do have some resources on that subject later as well. So some of you may have attended an earlier webinar in this series about how to disseminate your research. So I'm not going to talk about that today, but if you are interested in this subject, please contact and missed the webinar, please contact Victor after this, and he will be able to share the recording with you. Equally, in 3 weeks' time, there is another webinar on peer review. And so I'm not going to talk about peer review today, but please do come along in 3 weeks' time to that webinar if you'd like to know more about how to get involved in peer review, how to peer review, especially with the open science and reproducibility lens. So I'm going to start by speaking about open science practices at the phase of research that probably takes the longest, and that's designing your study and doing it. So let's zoom in a little bit on the research cycle. So you, based on the literature, based on your previous experience, plan a research study. You then go do it, analyze it, and write up the paper. You submit it to a journal and hopefully have it published. And then you disseminate your findings, either at maybe at conferences or on social media, and maybe with the support of the publisher there. A stage you may be less familiar with is pre-registration. And this is something that I'm going to talk about a little bit here and about why it's important. So what pre-registration is you publicly declare what your intended research plan is, and including your analysis plan. And why is that important, and how does it relate to open science? Well, key in open science is building trust between researchers and other researchers and researchers and the community. What pre-registration of research plans avoids is something called p-hacking or harking. So you may be familiar with this, but p-hacking is the questionable research practice whereby researchers do statistical comparison after statistical comparison until they get a significant result. And then they take that significant result and do harking, or hypothesis after results are known. And that means that they take the significant result that they found through trial and error and then write up the paper as though that was the hypothesis that they intended to test all along. Now, why is that a problem? It's a problem because that result may or may not be a statistical anomaly. It may be a false positive. And that means it's difficult for you as a reader of that paper to replicate that result because it was a statistical anomaly in the first place. It also means that you can end up wasting time on research that is never going to be able to replicate. So pre-registration helps us eliminate these questionable research practices because researchers need to declare in advance what they're planning on comparing. It's important to note that this is different. P-hacking and harking is different from hypothesis-free research, which is research that is designed and statistically powered specifically to be hypothesis-free and assess associations and relationships neutrally. But pre-registration is also beneficial for you as a researcher because it means that your research plan is out there and discoverable and citable. So you are increasing your visibility and chances of being cited while you're doing your research in the first place. And so there are benefits to you beyond avoiding things like p-hacking and harking from or other questionable research practices. So some of you may be familiar with this already, and some of you may not. But if you are familiar with this, almost certainly you're familiar with the process of clinical trial registration. So this is very well established and probably the most common kind of pre-registration because it is often a requirement by funders or it's legally required in some places. Many countries have their own clinical trial database, including Brazil, of course, and any registry in the WHO primary registry database will give the trial a unique number. And that unique number allows you as a researcher to link your publications and any open data, if you publish it, back to the clinical trial. And it allows you as a reader to find the publications associated with any clinical trial and vice versa. You can find the protocol from the paper that you're reading. These are public, so anybody with an interest, or be it patients or policymakers, can see the ongoing, planned and completed clinical trials. And the Brazilian clinical trial registry I wanted to highlight particularly because I think it is a really good example of embracing open science at the level of a repository. I haven't seen many repositories that allow presentation of the research question or scientific title in multiple languages simultaneously, meaning that those interested, like patients who might not necessarily speak English, can still access ongoing and completed clinical trials. What's also nice about REBIC is that there is a fast track of certain study types so that your protocol gets online faster and can be disseminated faster and read by more individuals quickly. When I last looked, I believe that this was for observational and interventional research involving Indigenous communities, as well as I think any studies involving COVID, but I do recommend looking at the website itself for the most up-to-date information. On a lot of slides, I have this resources icon and a QR code underneath for links to websites that I think might be helpful for taking practical steps towards open science practices. If you don't have a chance to scan the QR codes during the presentation, don't worry. The recording will be available and you'll be able to get the QR codes from that. If you don't have a smartphone, please contact me or Victor after this and we can send you the URLs directly as well. So pre-registering a clinical trial is a fantastic option for visibility, transparency, and trust. You're building trust in between your research and the readers, be it other researchers or the public themselves. However, you don't get, in the majority of cases, you don't get feedback from your peers by pre-registering a clinical trial. And if you're not doing a clinical trial study design, then these registering in such a database like REBIC might not be applicable or appropriate. And so that's where some of the other kinds of registration come in. So registering a study protocol has many of the same benefits as registering as clinical trial registration in terms of trust in open research, transparent research conduct. You can post a study protocol in lots of locations, so it's really flexible in that sense. So it could be your institution might have a repository. The Open Science Framework is a great place to post study protocols. And it means that your research is being read, shared, and cited before you have even finished the research. An added benefit of study protocols, if you choose, is that you can get feedback on your study design from peers during peer review by submitting the study protocol to a journal. So most cargo journals accept study protocols for a publication and they go through peer review. I think that everybody here is probably very aware of that moment when you get reviewers' comments back from an editor and it says something like, you should have included an additional control group here. And you think, great, okay, where's my time machine? And I can go back in time and add that control group in when I was doing the experiment in the first place. So by submitting your protocol in advance of doing the study, you can receive feedback on the study design and make adjustments before you do the research, and avoid doing maybe suboptimal research that's more difficult to publish when the results are in. Of course, publishing and disseminating the results is, I think, a key part for research. I think everybody would probably agree with that, either for career progression, but also in terms of ethical open science. And that's where registered reports can be really useful. So you may or may not be familiar with registered reports, but they're really a research paper in two parts. So part one is essentially the same as the study protocol that I just explained, and has the same benefits. Citable, get feedback from your peers on study design. The added benefit of registered reports, however, is that if your stage one protocol is accepted by the journal, that journal guarantees to publish the full research report, regardless of the significance of the findings. And I think that is can be very beneficial to you as an author. There's nothing, can you imagine the ease with which you could conduct the research if you didn't have to worry about the significance of the outcome, because you knew that it was already guaranteed for acceptance at a journal? I think it would be a weight off your mind, and it would avoid the reject, resubmit cycles that can sometimes happen when you finished a piece of research. So for a lot of you, registered reports might be a great option, and they are open for submission in some cargo journals also. So you're probably wondering what is the difference between a study protocol and a registered report. So I wanted to compare them, the similarities and the differences side by side, because they are so similar. So in terms of similarities, both improve transparency in research that's being conducted, because you make this public before the research is done, and it gives you an opportunity to get feedback from your peers on your study design. You also have the benefit of avoiding being scooped, because the research plan is already published, and so you get credit and recognition for the work that you're doing. Publications can also be added to your CV and be cited before the research is even completed. Where they are different is, so I mentioned that many journals accept registered reports, and that it comes in two stages, stage one and stage two. Now, not every journal that accepts registered reports will publish the stage one, and they will encourage you to post it on the Open Science Framework. So Carger does publish stage one registered reports, and you saw one on the previous screen, but I encourage you to read journal guidelines really carefully if you're considering submitting a registered report, just to make sure that you know what is going to happen to your research. And another difference, of course, is that guaranteed acceptance of the full study. So I mentioned that registered reports, if stage one is accepted, stage two is guaranteed acceptance, which is not necessarily the case for study protocols in all cases. I've put an asterisk there beside the guaranteed acceptance of the full study, and let me explain a little bit why that is. So the title of today's webinar was about ethical open science and ethical open research. So I want to, and I think this is where the philosophy of open science intersects with reality. So if your stage one registered report is accepted by the journal, they guarantee acceptance of stage two. But of course, that guarantee is conditional on you doing the research as you have explained in the methodology of stage one. You can't get your stage one registered report accepted, go complete a completely different study, and then submit those results as stage two. So in that case, the acceptance can be revoked. But of course, things don't always go to plan, and your research can be impacted by things that are totally out of your control. I mean, the pandemic is a great example of an enormous change to people's day-to-day lives that was totally out of people's control and completely unplannable for where hundreds of, if not thousands of studies went from maybe being in-person interviews to being Zoom interviews. So that's a change in your study protocol that you couldn't have anticipated. What's really important for ethical open science is that any changes are declared. So it may be that you need to get in contact with the journal editor if you have a conditional acceptance of a registered report to ask their advice on whether the necessary changes to the protocol require a re-review or not. Many clinical trial databases allow you to update the registration record, so you can always keep the protocol up to date there. And I think the most important thing is being transparent. So the great thing about pre-registering your research is that you can be held accountable for what you said you were going to do. And things change, and I think everybody is understanding of that. But the most important thing when you're writing results up and you did have to change your methodology, that you're honest about that and explain what changed, why it changed, and if there was any impact on the outcome measures, for example, or the conclusions that can be drawn from the study. So the most important thing in thinking about ethical open research is being transparent and explaining what happened and why. So the next topic I was going to talk about is planning for ethically sound research. And I'm not going to spend too much time talking about the approval process or ethical approval process, because I'm sure if you are doing research involving animals or human participants, you are very familiar with this process. The only things that I would highlight if you're maybe newer on your research journey is be aware of how often your institutional review board meet and plan ahead. So reverse engineer the date that you need to start the research from the date that you know that you need to complete the research, and work out when you need to get approval before that and when's the closest date that the IRB meet. It takes a very long time to get all the documentation in order, and you don't want to be caught out and unable to complete your research as planned because you didn't get your approval documentation in early enough. Another thing to think about for ethical open research is being vigilant and avoiding ethics dumping or helicopter research. So you might have heard of this. So this is really where researchers conduct research elsewhere, be it in another country or be it with a different community, without involving the relevant stakeholders locally. So in terms of ethics dumping, this usually refers to conducting research deliberately in another country for the explicit purpose of avoiding more stringent ethical research evaluation locally. So this means that you're submitting research to be approved by a local institutional review board, which is correct, but you are doing that exclusively for the reason that you know that the research wouldn't get approved were you to conduct it in your own country or university. Similarly, helicopter research is independent but related, and this is again relates to not genuinely involving local researchers. So in the previous example, you're engaging local researchers, but in a malevolent way, and not in a genuine spirit of collaboration. And by engaging local stakeholders in a genuine way, speaking to them before you even design the research study, you can consider how the findings are going to be disseminated for the benefit of those involved, be that local communities or patient groups and so on. So related to thinking about how this is going to benefit patient groups, think about your participant sheet. So most IRB committees will expect you to submit the participant information sheet if you're working with humans as part of the approval process. And this includes all the information that participants get about the study so they can give informed consent to participate. I think ahead to publication. Are you planning on sharing the data that you're generating? What are you planning on sharing? Are you planning on sharing videos, transcripts? Are you planning on reusing the data maybe for further analysis? Are you going to allow others to reuse the data? And how will the data be accessed by others if they request it? All of this information needs to go in the participant information sheet in almost all cases, so that when somebody signs up, they are truly informed about what's going to happen. And you as a researcher are not limited by what you can do with the data afterwards, by what information you included in the information sheet. So I put a little asterisk there beside sharing data, because I think that it's fairly self-evident that open data is really at the heart of open research and open science. However, sharing data needs to be done transparently and approached sensitively. So I mentioned the importance of the information that goes in the participant information sheet. How will the data be shared? How will their identities, with humans, how will their identities be protected? And where will the data be stored? Extra considerations, of course, need to be given when working with vulnerable populations or Indigenous groups as to whether the consent that you're obtaining is really free and informed. So, for example, if you're working with prisoner populations, their liberty is restricted by definition, and so extra consideration needs to be given about how you obtain consent to participate. Similarly, working with children or maybe adults with dementia, do they have a capacity to give informed consent and consider what your local legislation is around the age at which children can give consent on their own behalf. Another point you can think about and relates back to engaging with local stakeholders as early as possible is there may be cultural differences in the ownership of Indigenous knowledge. It may not be appropriate to seek an individual's consent for conducting an interview, for example. It may be necessary to get community agreement and assent and consent for involvement in any research and how that's shared. And related to that is when information that you are generating as part of your research is shared, how is the benefits and access to the benefits going back to the communities directly? Some of you may be familiar with the Nagoya Protocol. This is a set of guiding principles related to benefit sharing around genetic resources and was ratified by Brazil in 2021. And so genetic resources might be human DNA, it might be plants, if we're thinking about herbal medicines, or if you're involved in pharmacodiscovery, informed by traditional medicine practices. All of that can be, all of that touches on some of the principles that are in the Nagoya Protocol. And so I do recommend, if you're not familiar with it, to read it and make sure that your research is in line with what's outlined there. Okay, I'm going to ask Victor to launch the fourth poll and take the temperature of the room about how we're feeling about pre-registration now that we've talked about the importance of it as well as the benefits of it. So it's not just about the philosophically right thing to do for open science. I hope that I've convinced you that there are benefits for your career in pre-registering your study, not only because being transparent about the study design is kind of a foundation stone in building trust in research, but also you get recognition for the work that you're doing. I said at the start that the design and execution phase of research is the longest by a long way. And it may be years between designing a study and publishing it. And so by pre-registering your study and maybe publishing the protocol in a journal, you can get recognition and add the publication to your CV years before you publish the results of that study. Okay, I think the results coming in have slowed down, so if we can end the poll and we'll share the results. So I think many of you, just over half of the people that responded, plan on pre-registering your next research plan. I know that some of those people are probably already pre-registering their research, and so this is business as usual. And for those of you who are not sure, I do encourage you to think about this a little bit more, and maybe talk to your colleagues about what they think about pre-registration and whether any of your concerns about pre-registering are their concerns, and maybe you can talk about it together. There's a lot of resources online, some fantastic ones about registered reports and what if your research plan changes. Is it dangerous for you to publish a plan if it's then going to change anyway? So I do encourage you to read about that. There's some really interesting articles online about that. Okay. So now you've planned your study involving local stakeholders, ethically considering everybody, how you're planning on sharing the data, and what goes in the participant information sheet. You've pre-registered the protocol, you've done the research and analysed it, and now you're ready to submit it for publication. So again, I want to really focus on what practical principles from open science can we take into the publication process that are going to benefit not only society, but also you and your career. So here is the journey that a manuscript takes at Carger, in a Carger Publishers Journal, but this is very similar, if not the same, at most, if not most other publishers. I have overlaid some of the open science principles icons throughout the peer review process. But of course, this isn't just relevant at one stage. As I mentioned, you could code and data sharing is important at various stages. And we talked already about previous webinars on dissemination, and I'm not going to touch on that today. However, one of the most obvious things I think that comes to your mind when thinking about open science is submitting to an open access journal. And the most important thing I think to do with that is making sure that you are submitting to a trusted journal. So what do we mean by that? Unfortunately, there are such companies that in the industry we call predatory journals. And what do we mean by that? So a predatory journal is a journal that does not offer proper peer review. It's not going to offer you any support. They're doing very minimal, if any, checks on the manuscript that's submitted. And importantly, they're not most likely not indexed in any of the important databases where you want your research to be in order for it to be discovered, in order for it to be read and cited and downloaded and making that impact that I think everybody wants to make. There are several ways to check if the journal you're submitting to is a trusted journal and is not a predatory journal, because predatory journals can be quite aggressive in some of their marketing tactics and emailing you a lot. So one of the most straightforward ways is submitting to a journal or a publisher that you know that has open access journals. So Carger offers open access publishing within any of our journals, and we have over 30 gold open access journals for you to submit your research. Of course, you don't have to take my word for it that Carger is a trusted publisher. You might want to consult an independent adjudicator. And so another important way that you can check if a journal is trusted or not is checking if they are in some of the organizations that do quality checks of journals. So that is DOAJ, the Directory of Open Access Journals, and if the journal is a member of the Committee on Publication Ethics. So both of these are independent organizations that check the quality of journals and to make sure that they do all the things that a predatory journal doesn't, such as checks on submissions, doing a proper thorough peer review, indexed in all the relevant databases so that your research gets disseminated and supports you post-publication with dissemination of your research, promotion, as well as anything else. I think in today's day and age, I can't talk about ethical open science without talking about generative AI and ChatGPT. I'm sure you have heard about ChatGPT and generative AI, and this is tools and software that can give you an output of new text or images based on an input prompt. This has been all over the internet. I'm sure you're very familiar with it. The famous ones are ChatGPT, GPT-4, DALL-E, which creates images, and Bard from Google. So why is this coming under ethical open research? The most important thing, particularly for us as a medical publisher, is the fact that generative AI can't check the accuracy of the output. And this can be really dangerous if we're talking about healthcare research, because the research that you're probably doing impacts directly patient outcomes. And so it's really important that what you publish is accurate and can be trusted by researchers, policymakers, patients, and other readers. There's also a danger for copyright infringement. So what generative AI can't do is check if it is infringing on another's copyright. And so you may inadvertently be taking text or images that has already been created by somebody else. And that can be a copyright infringement, which is a legal matter and can be quite serious. And so most publishers have official policies on the use of generative AI in publications. I've included a link to Cargo Publishers Policy, which is informed by the Committee on Publication Ethics that I mentioned, that organization. And the first thing we say is that generative AI tools can't be listed as authors on manuscripts because they don't meet our authorship criteria. But it's important that if you do use generative AI as part of your research, that how the accuracy of any outputs is checked. And in the interest of transparency, that you include any inputs and any raw outputs as supplementary material. If we consider that part of the data set, it's making the original data underlying the article available, which again is one of the cornerstones of open science. However, I don't think it is a shock to hear that people don't share data. And so that might be people don't upload data to repositories, but unfortunately, it also includes data availability statements, which are very common on articles now and are published on every Cargo article, every Cargo research article that say data available on request. And there has been several studies now that when requested, the data isn't provided in, unfortunately, the majority of instances. And why is this so detrimental? We talked about how key hacking can impact the reproducibility of a study because the results described may or may not be a statistical anomaly. And if there's a statistical anomaly, it means that you will never be able to reproduce that result. If the data underlying the research isn't available, you quite literally could never reproduce the results that the authors obtained using their own data. And so the lack of data sharing kind of fundamentally undermines trust in the research process and can impact not just those researchers that don't share their data, but undermines trust generally in publications if findings can't be reproduced. So I hope that I've impressed the seriousness and the importance of data sharing on you. We've talked already about when thinking about sharing data and code, think about what can be shared. And we talked about that in terms of informing participants about what's going to be shared ethically, making sure that it can be shared ethically, can be shared legally, and that it's permitted by the individual giving consent. So I won't keep talking about that. But practically, you probably want to know where. So repositories are like cloud-based folders for large data sets to be shared or to be stored indefinitely. And there are lots of different kinds of repositories. Some of your institution might have a data repository. You might prefer to use subject-specific databases. That can be really helpful for discoverability because everybody knows to go to binding DB for data of that type. It can be generalist. If you have kind of mixed data sets or a lot of collaborative research, doesn't neatly fit in specialty specific repositories. So something like Figshare and Dryad or GitHub for code and CodeOcean can be really helpful there in sharing data, making it available without needing to fit into the kind of specific requirements of specialty databases. However, similar to needing to use a trusted journal, it's really important that the repository that you're using is also a trusted repository. So what does that mean? A trusted repository should give you a unique identifier for your data set, and that means that the data set can be cited and you get the recognition for the data. They should also have a persistency plan. So that means that the repository isn't going to disappear tomorrow with all of the data disappearing along with it. And how you can find this out is always on the repository website, but many repositories meet the expectations of some certification bodies. And so you know that if Core Trust Seal has said that this is a certified repository, that it meets kind of all of the requirements under open science. Because ultimately, a DOI that's assigned or a unique identifier that's assigned is forever. And so you want for your data to be able to be reused indefinitely. And the trustworthiness of the repository really relates directly to that. And the other big question around data sharing is, when are you going to do it? And from talking to researchers, I know that a big barrier around data sharing, apart from not being sure what they can share, is the sheer task of sharing data. Research studies go on for years and years. You've got years worth of data, gigabytes worth of data. Maybe it's disorganized in sheets all over the place, and researchers don't even know where to begin to start sharing their data. And so most advice suggests that before you start research, you have a data management plan and you discuss with your colleagues where the data is going to be shared, if the data is going to be shared, where are you planning on sharing it, and the kind of metadata that is going to be necessary to store about the data in order for it to be shared and reused. Some subject-specific repositories absolutely require really detailed metadata, and indeed some generalist repositories will expect detailed metadata about your data in order for it to be published. So this is very difficult and time-consuming to do, full stop. It's extremely difficult and time-consuming to do after you've collected 3 years worth of data and you're trying to organize it in a way that is acceptable to repositories. So I do recommend starting as soon as possible with a data management plan, and discussing with your colleagues so that they also replicate the same good data storage principles, so that when it comes to publishing your research and publishing your data, that it's a fast process and not a painful one. So I put a little asterisk here around the importance of metadata, and that relates to how reusable and reproducible the data is. Because if you can't understand, if you've ever tried to reuse data from maybe a generalist repository, you can download an Excel sheet and can't understand what any of the columns are because they're very badly labeled, or what anything is. And so good metadata will avoid that. And the absence of metadata means that you can't actually reuse the data, and so it isn't reproducible. So the next topic that I wanted to talk about when we're thinking of ethical open research is exactly that: reproducibility and replicability. Two terms that have slightly different meanings depending on who you're talking about. But for our purposes, I just use reproducibility, and I mean finding the same findings again, either using the researcher's original data, or you going to another location with your research team and conducting the same research and finding the same findings. So way back at the start, I asked you, what do you hope to achieve when you're doing research? And everybody answered, and there was different bullet points there, had different weight for different people. But fundamentally, what all of these things are about is trust. So in order for your research to be cited and to make an impact in the field, it needs to be trusted. And a key facet of trusted research is that others can find the same result again and again. So if a result is reproducible, it can be considered a trustworthy result. If you're thinking about maybe the COVID vaccine, this was found to have an effect wherever the clinical trial was done. Had the results been different, wildly varying between different countries, it might not have been so well trusted by the public and by other researchers. And so reproducibility is really key to trustworthiness of research. And that is key to not only open science, but also personally for your career progression. And so practically, what to think about for reproducibility and replicability is how your data is shared and how your methods are shared with reproducibility in mind. So you might have heard of the FAIR principles, and these are a helpful list of principles that you can refer to when getting your data ready for sharing, to make sure that it's in a location and in a format that is as reproducible as possible and as reusable as possible, in order to build up that trust in your research. But of course, if your methods aren't reproducible, then your results can't be reproducible. And so by this, I mean, can another researcher, based on the information, say in your study protocol, go and repeat the same experiment? Because if they can't, then there's no way for them to test whether or not the results are reproducible. One suggestion that a colleague gave me about how can you test if methods are reproducible is, can your mother give your paper to your mother, and can your mother understand what needs to be done? Now, I don't know if that is applicable for everybody's research. I certainly don't think that my family would have appreciated me asking them to read any research, but I think that is a good mindset. I think it's very difficult when you are doing your own research that it becomes intuitive, that you know, of course, that A follows B follows C, and it doesn't need to be said. But to an independent party, not a lot of those steps are clear. And so I think that that's a good mindset to be in when asking yourself the question, are my methods are my methods reproducible? And if that has kind of piqued your interest in reproducibility and the importance in it for not only open science, but generally trust in research and avoiding waste in the research cycle and advancing, I think, science in general, I do encourage you to get involved in the Brazilian Reproducibility Network and become a local advocate for ethical open research practices. And there is a fantastic YouTube channel actually from the Brazilian Reproducibility Network that has loads of videos on there, so you can expand on what we've been talking about today and learn even more. And with that, I wanted to ask Victor to launch our last poll around resource sharing and making data and code publicly available. So I think I've talked a lot about the practicalities of it and that it can be very time consuming and that it needs thought at the start of your research plan and during the research plan about how you're going to do this. But I hope I've convinced you of the benefits of this as well, not only for open science principles, but again, similar to publishing a study protocol, your data can be cited. That means that the visibility of you and your research is increased. The reach of you and your research is increased. And you get recognition for all of the parts of the research cycle that impact you, not just publishing the results in a journal at the end of it, that you really get recognition for all of the work that goes into maybe that 1 or 2 papers. So I'm really happy to see this result. I think that it's fantastic. I think open science and data sharing is becoming more and more required by funders across the world. I think that this is the way that things are going. And I think that if your funder doesn't already require or your institution doesn't already require data sharing, that this is the perfect time to start thinking about it, because if and when they do require it, you will already have the metadata practices in place in your group so that the transition to sharing data is not a painful one. So good luck on the journey there. If you are ever not sure, it seems like a lot of your colleagues are already involved in doing this. So it sounds like there's a lot of help locally. Okay, so I said that I really wanted to focus on practicalities today, and I do hope that everybody here found something in what we talked about that they can take away and back to their research group, back to their research to embrace open science a little bit more, be it big or small. Ethical open science and open research is transparent. We talked a lot about that today. I know you're extremely busy, and this is maybe for some of you a new field that you feel like you have to keep up to date with in order to, build trust in your research, make an impact, have your research make a bigger impact for your colleagues and for others. And that's where Carger Publishers can support you as we're supporting researchers throughout the cycle of knowledge. So we have in the past run in-person workshops at conferences on this subject. We also offer online training in multiple languages on how to conduct ethically sound research. And that includes things like responsible authorship practices that I mentioned earlier that we didn't have a chance to talk about today. The resources are interactive, the training is interactive and available in Portuguese if that is your preferred learning language. Of course, on the other side of research is peer review, and we provide training for peer reviewers through courses online that are interactive again. We also have a series of webinars on peer review. Reproducibility is a screenshot here, as well as the importance of peer review on the Carger YouTube channel. So please do go and have a look at that. And if peer review is something that you are interested in, either because you would like to get started in peer review, or you are peer reviewing and would like some support on how to peer review and how to peer review maybe different kinds of studies, and particularly with open science and reproducibility in mind, to build that trust in research, please do come along to the next webinar that we are doing in 3 weeks' time on exactly this subject. And again, with lots of focus on practical changes that you can make and things that you can take away to immediately benefit you and your peer review. And with that, I will just reiterate, if you have any questions, please don't hesitate to contact me or Victor. Both of our email addresses are there. Maybe you've already heard from Victor, and the recording of this will be shared later with the QR codes in there for any of those links. And so with that, I will hand back over to Victor, and thanks everybody for listening this long on a Friday afternoon.
Thanks a lot, Grania. I think it was a great presentation, and actually a lot of reference links and further material to support the discussions in the field, which is always very valuable. We have some questions here. Let me just check. First of all, regarding data sharing, if it's also common to share research data in the field of human and social sciences, or if it's more common like in clinical research and health sciences research?
This is a really important question, I think, because it is a little bit easier, I think, for in terms of ease, it's easier for those that are maybe working in a lab with cells or with animals to share data. It's slightly harder if you're working with clinical data, because you need to think about informed consent, you need to think about anonymization. It's even harder, I think, when we're to share data when we're talking about humanities and social sciences, because of the nature of the data itself. It's generally very heavy on interview transcripts, which are almost by default identifiable. And so it can be very difficult for social sciences researchers to embrace open science while also maintaining the anonymity that they promised their participants. So however, the same principles that I was talking about do apply. So I think it is necessary to think about from the start what you are planning on sharing. It's not impossible to share data in open science, in health sciences, in humanities and social sciences. I think it just needs to be planned and thought about, maybe even a little bit more than in health sciences research. For example, if you're working with interview transcripts, it may not be possible legally, ethically. You might not have permission to share the full transcript. However, if you're doing sentiment analysis, you might be able to share the results of that sentiment analysis and the output from that. So I think that it's less common because I think it's harder and requires more thought and planning for data sharing. So again, this is the emphasis on thinking in advance what you're planning on sharing, and putting the framework in place so that you can share. But I think that it will become more common over time as people get more confident, and the field itself starts to expect this as a normal part of the research cycle.
Great. Just to mention, we have also the Go Fair Brazil group. So I think they also can have some further material to support in this field. Recently, not that recent, but we also had the launch of Lattice Data, which is also a data repository from the Brazilian Ministry of Science. and also Cielo data, which is quite strong. Cielo, a great case, success case in the open science in general. So just to mention these three items for the data sharing field. There is one question. Thanks for the lecture. It was very interesting, and I could see myself as a researcher in different moments. However, my question is, as an editor-in-chief, many of us are editors in small Brazilian journals, and we are struggling to achieve to be indexed in good databases. I believe that one of our worst problems is to get fundings. In this context, do you think the open science principles could be compromised if we need to charge for the APC? I'm not talking about predatory behaviors or extremely high costs that we can see in different open access journals. I'm just talking about the basic costs that we have in the editorial process.
Yeah, I really feel for you, because I think that is something that every publisher struggles with, be they a small publisher, a big publisher, of not wanting to introduce barriers to authors, right? Like previously, before open science, the barriers were all on the reader, and now, through open access journals, we're making it more open. But of course, then the burden for making that accessible is placed on the authors. I think what is great that some publishers are doing, and maybe Victor can speak a little bit more about this, is working directly with funders and institutions to shift the burden of cost from the authors directly onto maybe the libraries, as historically had been the case. But I think that it's not a impediment to embracing open science by needing to charge APCs. I think that unfortunately that is a reality, even if it costs money to run a journal. I'm sure you're very aware of that, and where the money comes from is the question mark, not whether or not the journal costs money to run. So if it isn't, there are different revenue thoughts that people have in terms of working with maybe charities. Some big organizations support, like the Bill and Melinda Gates Foundation, for example, is an example of a funder that will support APCs directly. I wish that there was a good answer, but I don't. What I will say is that I don't think that it compromises embracing open science by needing to charge open access fees. Unfortunately, that is a reality. In fact, it's an indicator of the fact that you are a quality journal and not a predatory journal, because it's much cheaper to run a journal that you're not doing peer review and you're not checking any quality and you're not promoting your research. So all of that benefits for your authors costs money. And so, yes, I think it's not, you're not compromising open research by this financial reality, I think.
Yeah, I don't know if there is the possibility to have like a hybrid model where part of the journal cost is funded by a funder, and also part the authors would need to pay a APC, but then a smaller APC with some very transparent communications on these costs and so on. But definitely a challenge. But it's good that you said it would not compromise in terms of open science and open access. Yeah. Regarding protocols, do systematic review protocols follow the same rules and flow as primary research protocols?
Yes, essentially, that's the short answer. So not all journals accept systematic review protocols for publication. It's very much on a journal by journal basis. So I would check the guidelines of your journal, but it's very similar actually to primary research. I'm sure if you're engaged in writing systematic reviews, you're already aware of Prospero, the place to register systematic review protocols and check that the systematic review that you're planning isn't already ongoing and published. But yes, the process for peer review and submission to a journal for systematic review protocols is the same. As far at Cargo Publishers, we think of them just as another kind of research study that people are engaged in.
Okay. Let me just try something here.
And while Victor is doing that, I will also say that the importance of registering systematic reviews is also the same as registering primary research. As I said, we consider them just another kind of research study. And so all the benefits of transparency and avoiding, like building trust through transparent declarations is the same for systematic reviews as primary research.
And just answer because there was a case of a person willing to speak, but I don't have any permission like to open the microphone of the attendees. So if you could type your question, we will address to Grania. There is another one just asking if you could elaborate on what do you think are the main differences on the open science sphere between the countries? How are you seeing these aspects?
I think that I could talk about this for a while, because I think that there are a lot of differences, but I think that it ultimately comes at the heart of the differences is access to resources. I think that countries that have a very well developed open science policy, endorsed at the government level, have the resources to have agreements to pay, for example, open access charges, or have big data repositories, because storing terabytes of data is extremely expensive energetically and therefore cost-wise. I think also resources in terms of training for researchers is a huge difference that I see from talking to researchers. I think that grassroots organizations with backing from ministries of education, like the reproducibility networks, are really great examples of showing that there is global, it's a global network. There's a global interest in open science and reproducibility. However, at a university level, I think that where you learn how to do research is quite early, I think, in your career, and very few universities are teaching reproducibility that I'm aware of as part of the core curriculum for those degrees. Actually, any degree that can lead to a research career. So I think that is generally lacking globally, but I think that, like, Brazil has a reproducibility network. There is a community of people who are engaged in this, and there is infrastructure in place to support infrastructure and resources to support open science, and that isn't necessarily a global phenomenon. And so if there's as a scientist, there's a bit of a lottery based on where you are around the world in how much training you get in open science. And then when you develop your awareness, maybe watching YouTube videos or reading articles about open science, there's a limit to how much institutional support is available based on where you are. Though generally, globally, we see a shift towards open access publishing and open science.
Thank you. I'm not sure. Are you able also to see the questions, Grania?
Oh, yes. Okay. Oh, I see the question, the person that could not unmute, about p-hacking. So for those of you that can't see it, this is about p-hacking that I mentioned. This practice is a complex problem in science, and I see both scientists and publishers as part of the problem. Easy to point fingers at scientists for p manipulation, but we must also remember that this practice may emerge from the publication process. True, I agree. If positive, significant results are more likely to get published and scientists are under pressure to publish, then the practice of p-hacking is stimulated by journals' tendency to reject studies reporting negative, not significant results. Nevertheless, non-significant negative results are as important as significant and positive results in science. My question is, what if publishers created a space for the publication of non-significant negative studies, open access and free of charge? I completely agree with the sentiment that is in there, that nobody who becomes a scientist does so deliberately to mislead people and to manipulate their data to get more interesting results. I don't believe that anybody deliberately enters science like this. I think that the incentives that are in place, in terms of career progression and in terms of securing funding, and in part publication, creates the space that some researchers feel obliged to dress up their results to be more than they are in order to get that article published, get that grant, get the promotion. So in answer to your question, can we have a space for publishing null results? I will say that every cargo publisher journal will consider null results for publication. Again, this comes down to an editor preference about whether they get published. But as you say, a negative result or a null result can be just as important as a significant result. There's been some fantastic examples of really high-profile null results being published in the last few years that are really impactful. In health sciences, and so I think that part of it is a mindset for editors, for researchers, about how null results are thought about in the lab, in research, and when writing a manuscript, about why is this null result important? Is it going to stop pursuing this avenue of research that isn't going to go anywhere? It is a big problem in research, this desk drawer phenomenon, whereby a lot of research is not published because it's not significant. I think I'm talking about the importance of registering your research and how common it is for people to register clinical trials, but we know that a huge proportion of clinical trial results are never published. And there is an assumption that is because there was no effect. And so I think that everybody has a part to play in changing this. Everyone has a part to play in changing the attitude generally towards null results. And I'm not trying to pass the blame, and I'm definitely not blaming researchers, but I think that why I'm talking so much about pre-registering your research, sharing your data, sharing your code, is because I think that the institutions that decide on career progression, for example, the university that you work in as a researcher or the body that gives funding, I think needs to recognize the importance and the value added of all of the stage in the research process, and needs to give weight to the sharing of data and the sharing of code. This is not a novel insight. I think that there's a lot of people pushing for this quite heavily. And I think that putting less emphasis on the importance of a significant journal article and putting more emphasis on publishing, the importance of publishing protocols and making your data publicly available, as well as publishing null results in journals, will remove the incentive in the first place for researchers to feel that they need to p-hack in order to do all of the things for their career that we talked about earlier.
Great. Thank you very much. He said, thank you. Now a personal question, like with Cargo, with our journals, like, do we recommend that the data is shared, and do you think in the future will be like a demand that not just Cargo, but publishers actually request that the data is shared somewhere? How's this landscape right now?
So, so at Cargo Publishers, all research articles have a data availability statement, and that is mandatory. And there has to be information there on where the data can be found. It's not acceptable to say the data is not available to be shared. What we do understand as a health sciences publisher, and I think is reflected in some of the answers to the question on whether or not you will share data, is that there are ethical restrictions put in place on what can be shared. And now that maybe I talked about, the research was done before you even thought about data sharing. And so it wasn't in the participant information sheet. And so you don't have permission to share the data. And so it needs to be accessed, to publicly share the data, and needs to be accessed in a different way. So I think that is, we require transparency at Cargo about where the data is and how it can be accessed. And we strongly encourage sharing data. And we make all of our supplementary material available on Figshare using a CC BY open access license, which means that anybody can freely reuse it, provided they give credit to the authors of the data. But what is happening more and more is funders themselves are saying, as a condition of funding, not only does your research have to be published open access, but the data needs to be shared. So in North America, the NIH in the US recently said that that is the direction that they're moving in, that for benefits of science to be distributed more widely, and that includes data sharing. And making data publicly available. So I think that is where things are moving in general, globally, at different paces. I think in different fields, we talked about the difference with social sciences and humanities, that different fields are moving at different paces, as well as it's being pushed at different rates in different places.
Okay, amazing. Here in Brazil, we just had actually like a task force group for the Open Government Partnership, and one of the topics there was actually how to enhance and improve open science practices. So all of these publishing data, also the research assessment, trying to include all the metrics rather than just impact factor in the evaluation and so on. A lot of conversation is going on in this direction. To improve this scenario locally as well. As an information CAPES, the consortium is also looking into transformative agreements, so also to support much more this APC funding model for the Brazilian authors. So that's something perhaps in the close future we'll have a new support from the government. Let's keep an eye on. So I think Brazil and Latin America in general, we are doing some great moves and steps into some open science practices. Mm-hmm. And I think that was a great discussion, great presentation. Thanks a lot, Grania. It was a pleasure. Thanks for your kindness. And for those who haven't registered for the next one, we have a next one on best practice for peer reviewers. So if you're also interested in this topic, please join us in our next conversation. And so wish everyone a great weekend. And thank you.
Thanks, everyone.
Muito obrigado, pessoal. Um abraço, bom final de semana. Tchau, tchau.